Good afternoon, hey, Archer. Okay, let me share my screen. Settings. Let's look at something here. Okay. Okay, everyone. Good afternoon. How are you guys doing? Okay, we got some more people. Let me let everyone in. Um, let's see here. Okay. So I'll wait for a few more people to come in. I'm going to write down the extra credit problem from the test. So I was going to talk about that one yesterday, and I didn't get a chance to. So this is actually a fun problem. You don't need any really advanced math or anything to solve it, but you do need to kind of present an interesting argument. Did anyone end up thinking about this one a little bit um, over the last week? So if you recall, the extra credit problem was oh yeah, definitely. I'm still behind on posting stuff. I will get everything posted tonight. Okay, let me see here. Let's try to run this one. Okay, that's fine. So extra credit problem. So it said in a party, at a dinner party with 6 people, at a dinner party uh, with 6 guests, show that there must exist a either one of the following. Um, uh, at least one of the following. a group of 3 mutual friends, or 3 mutual strangers. What do you guys think? I know this is an unusual type of problem and we hadn't seen it before. But I was just curious to see if anyone could have some thoughts about it, or sometimes the hardest thing with these problems is even just kind of trying to understand what it's even saying and what it means. So did anyone think about it? Anyone want to share an idea that they might have had, or and you can also message me in chat, but it'd be great to hear some ideas if anyone wants to share. And I by no means expect uh, um, let me see. Okay, so let me see. I can look back on some students mentioned that they. Let me take a look. But yeah, anyone have just a show of hands? Hit yes if the question kind of makes sense, and also no if no idea what's going on here. Okay, it looks like a lot of people instantly hit no. Um, so now I'm curious. Those of you who say no, um, uh, what part? I'm curious to know like what part of it, like what part of the wording, like just forget about the math. Like, is the what part of the wording is what part of the wording throws you off? Like what part of the situation, what the question is asking, throws you off? Anybody who said that they were like kind of lost, could you guys kind of pinpoint like what phrasing or what confused you? Okay, so Gabby asked a good question. Are 3 mutual friends and 3 mutual strangers kind of like the same thing? That's a very good observation. That they kind of are. Of course, you know, if you guys have you guys ever been to like a small party, well, maybe a larger party or whatever, you're gonna have first of all, what's a mutual friend, right? I mean, 3 people are mutual friends. Is that clear to everyone what that means? So, uh, yes, if you have a sense of what that means, like if A, B, and C are mutual friends, what does that mean? You might have heard that phrase. So, like, imagine you have 2 friends. So, like, imagine you are Alice, right? Let's say, and you have 2 friends, Bob and Cindy. What does it mean for the 3 of them to be mutual friends? All 3 of them mutually friends. Because you're friends, let's say Alice is friends with Bob and Cindy, right? It's not guaranteed that Bob and Cindy are friends. Maybe they haven't met each other. However, if the 3 of you are mutual friends, that means that you know Bob, Alice knows Bob. Let's just say Alice knows Bob, Alice knows Cindy. So Bob, uh, so Bob and Cindy both know Alice, but it means something in addition to that. It also means every pair of friends that you can make from that group know each other. So it means that also Bob knows Cindy. So the 3 of them all know each other. That's what 3 mutual friends means. So maybe I should have been clearer on that terminology. And so what about 3 strangers, 3 mutual strangers? Is that clearer now what that would interpret, how you would interpret that? So basically there's 3 people that all know each other, and there's 3 people, or I should say, or there might be 3 people that are all like nobody knows each other. Does that kind of does that clear up a little bit of the wording? Well, is a situation like what kind of what we're looking for? Like if you have 6 random people, right? Some of them know each other, and some of them don't know each other. So let me kind of try to reshare this. Okay. Oh, okay, that's a good point. Gabby asked a question. Who started this dinner party? The person would have to know all the people. So, okay, that might be true. So there might be one person who knows everybody. We're not making that assumption. Maybe it's kind of like, they all got an invite from, um, I don't know. They all got a. It could be some sort. Yeah, Archer did. Yeah, it could be some sort of wedding. Um, or maybe let's say like um, I don't know. If you guys have ever been to like or heard of the company like Meetup, they would host events like say, oh, I'm interested in going to some event, and you just sign up for it and you go there could be like a surfing meetup or like a trivia game meetup, and you just show up and they pair you with people that you might know and you might not know. Maybe you go with a friend. So it's saying 6 people show up somewhere randomly. Um, one of the following has to happen. There has to be a group of either there has to be a group of 3 people that all know each other, or there has to be a group of 3 people where nobody met each other before at all. So anyone have any thoughts on how we can kind of start to draw possible scenarios here? Because this is actually quite a nice little problem. And you can also, once you understand it, you can ask your friends to think about it. Anyone have any ideas? And you've actually, you have the tools to answer this. How could we represent a group of 6 people where some people know each other and other people don't know each other? Actually, Gabby, yeah. Gabby made a great comment. It's literally a breakout room. So if you just make a breakout room with 6 people, there's going to be some of you that know each other. Look, should we do that? We could do it with 6 people. Then, so let me kind of give you. Let's work through kind of how you can draw the picture, and then I'll put you guys in breakout rooms, and we'll see if this statement is always true. So, any thoughts on how you can? Any thoughts on how to draw this as a picture? Anyone have any ideas? It's related to something that we did before. Nice, Gabby. Yeah, uh, uh, something like the handshake problem, right? Where we have dots representing people, and maybe we draw something to represent knowing and not knowing. So it's just slightly different this time, because now we don't have handshakes. We want to represent people knowing each other, which is kind of like a handshake, and we also want to represent people not knowing each other. So we can draw the 6 people. What idea might you have to represent 2 people that know each other, and versus 2 people that don't know each other? How could we draw that differently on the graph?
You could draw a dotted line.
Yeah, maybe a whole like a solid line if they know each other, and a dotted line if they don't know each other. Or technically, you actually don't need. You technically maybe don't even draw anything if they don't know each other. You only draw a line if they know each other. But because for this problem, we want to also understand when people don't know each other, it's going to be helpful to visualize instead of like a solid line and a dotted line, or instead of a solid line and no line, which kind of we can get the same information. It's going to be easier for us to visualize. Gabby suggests a good idea. It's going to be easier for us to visualize if we just do different colors. So let's just kind of go through an example here. Alice, Bob, Cindy, Dan, Evan, and Frank. And I'm going to do red means that they're strangers. They don't know each other. And blue means that they are friends. They know of each other. They have a connection. Maybe like Facebook friends could be the they could be the requirement for being friends. Okay, so here's some random graph. I'm just going to color them randomly. Blue, red. Okay. I'm going to start with Alice. Let's say Alice knows Bob, Cindy, Evan, but Alice doesn't know Dan, and she doesn't know Frank. Then let's go to Bob. Bob knows a bunch of people. Bob knows Alice. Bob doesn't know Frank. Let's say Bob knows Cindy, and Bob does not know Dan, but Bob does know Evan. I'm just coloring these randomly. And then you can do the same thing over here, like this, like this here, and maybe I should just do this one here. I'm just doing these randomly. Red, and then red. Okay. So this is one possibility. It looks kind of complicated, but this is one kind of arrangement of how 6 people might know each other and not know each other. Yes, if that makes sense, what this represents. And no, if it's a little bit confusing, kind of what I drew here. A little confusing. Yeah, so this is kind of like the handshake thing, but we're just adding colors to represent people that are friends with each other and people who also don't know each other, who are strangers. So it's very similar to the handshake thing, but it's just like one extra idea. All right. Can anyone, I just drew this picture totally randomly. I had to connect everybody to everybody else with at least one color because you show up in a room, each person, you're either friends with them and you know them, or you don't know them. You never met them before. They're strangers. Right? So that's the only possibility. So everybody is connected with everybody else. Okay, can anyone give me an example of a group of 3 friends that all know each other? Are there a group of 3 friends that all know each other? Does anyone see an example? Okay. Kanjit said F, Frank, Alice, and Bob. Hang on. Well, Frank and Alice and Bob, the problem there is I'm gonna kind of, maybe I should have done a different color. So these guys, let me just see here. Oh, perfect. Let me do it the green. So these guys here, they don't. Okay, yeah, blue is friends. So so that would not work. Let's see. Colby says A, B, and E. Yeah, nice. Alice, Bob, and Evan. These guys. Let me just kind of draw this out. This does form 3 friends that all know each other. Olivia suggests Alice, Bob, and Cindy. Nice, that also works. Alice, Bob, and Cindy. So what's the thing? If we want to look for 3 friends that all know each other, what's a simple shape that we look for? Bob, Cindy, and Evan also looks nice. Okay, so 3 friends that know each other is so 3 friends that know each other. three mutual friends, not friends, but friends, three mutual friends is the same, is equivalent, I'm going to put it like a double arrow, to a blue triangle, a blue triangle. Okay. And three mutual strangers, what do you guys think that shape would be? It's going to be a red triangle. Okay, cool. So we got some blue triangles. Do we have any red triangles in this diagram? Can anyone see any? There might not be, but let's see. Are there any? Where do you guys see a red triangle? Let's see. Oh shoot, I forgot. I'm sorry guys. I didn't connect F and D. So I'm actually gonna make it blue. I didn't connect. That looks better now. Now everybody's connected. Okay. ADF. So because I drew it as blue, it made it not a red triangle. If I made it red, it would have worked. But if you look in this picture, are you guys convinced that if you look through all the red edges, you can't find any that make a full triangle? Nice, there are none. So in this case, the only situation that we have is we have a few groups, we do have a few groups of three mutual friends. So they are, I'll write it in blue. What did we say? We said ABE. ABE we found. We found ACE. And was there another one? BCE? So we found quite a few blue triangles. Oh, let's see, AD. Oh, okay, interesting. So a guy made a comment here that you can have a red rhombus, but that's not exactly what we're looking for. We want to find a shape where everybody mutually doesn't know each other. So in order for us to be interested in a red rhombus, what we would want to have is that the red rhombus would be like this. So this is a nice shape. And then, but not only that, but then the corners are also red. So every pair in that shape is going to be red. Every pair of points. And did I get? Oh, I forgot ABC also. Thanks, Roger. Good. So I think those are all the groups of. All right. So this is an example that. Oh no, it's okay. Frank is friends. You know, it's a little bit lonely there, but he knows Dan, so it's good. All right, so this is an example of a drawing, just a random drawing. I picked things blue and red randomly, where there's four groups of three mutual strangers that you can possibly create. Oh, sorry, mutual friends. And there's no groups of three mutual strangers. So the theorem is true, that there is at least one case that happens. All right, so what I want you guys to do is I'll give you like if you either have if you're on a computer and you can do like Google Draw, just do one randomly, just like I did, blue, red, green. Sorry, blue and red, and draw the 6 dots and see if you can see what happens. See if you can find a configuration. See if you can make a configuration where there's no triangle, no blue triangle and no red triangle. And also, so before you do that, try this out with 5 people. So can you draw a similar shape with 5 people, and you color the edges to not get a triangle? Well, in this case, there is some similarity to the handshake theorem, because like if you know, if Alice knows Bob, then Bob knows Alice. So that's kind of what we're talking about in terms of being like being friends. But the core idea is a little bit different. So please just try out one example, and just draw either on a piece of paper. Do you guys have like maybe different color pen? And just kind of, I'm going to be curious. I want to see at least like, so I'm going to ask you guys to turn on your cameras and at least see 8 drawings. I want to see 8 drawings, and then we'll move on. So let's see if we can get to 8 drawings total. And just message me when you have a drawing, and you just put it up. You don't have to say anything. Just put it up in the camera and tell me which. You can either share your screen if you want to do annotation. Oh yeah, okay. So so either 2 things. You can either draw 6 people just like we did, color them randomly, and find the triangles, or you can try to draw 5 people and see if you can do it in a way that there's no triangles at all. So if you draw 5 people, it's going to be just like 5 dots, and then you're going to color the edges between them. It's going to be kind of like it's going to be like a pentagon, but with all of, you're going to do the edges and all the diagonals as well. So I'll give you guys a few minutes to think about it, and maybe I'm going to put you into some breakout rooms, and just kind of, you guys should share some ideas on these, and maybe one person could share their screen, and everyone could. I'll just put you quickly into some breakout rooms. Let's see. Yeah. It would be kind of cool to in the breakout room to see if if you've ever met somebody before, and draw a diagram that represents if you guys have ever met or not met. Do you guys want to try that? Like if you've met in real life, or if you were friends before in real life, before coronavirus. Okay, so yeah, so this is maybe a fun activity. So the goal is put one person in the room. The youngest person in that breakout room will share their screen, and or they can share like their video, and make a little dot and put a name for each person in your breakout room, and then just pick 2 colors like blue or red, or pencil and red pen or something, and then draw a graph just like we did with 2 colors that would represent, you draw if people have never met before kind of this class, if you kind of were friends in real life, you would draw maybe blue, or if you have never met before only in this class, then you draw red. Okay, so you might meet some new people that you haven't met before, so find out who the youngest person is and then draw this thing. And please turn on your video in the breakout room so that it's not all blank screens. This way people feel a little more comfortable. Okay, sound good? Thumbs up if you guys are okay with this. Awesome. Okay, I'm going to break you guys into the breakout rooms, and let's see what happens. Let me see, actually. Okay. Okay, there's going to be some rooms with 6 people and some rooms with 7 people. So there's going to be 4 rooms overall. And Svena, yes, you. So what we're going to do is what we just did is we had this. We went over the extra credit problem, and we didn't quite finish it yet. But just kind of showing you some of these ideas that when we talked about mutual friends, 3 mutual friends, we were talking. What that meant was 3 people who all know each other. So Alice, if you have Alice, Bob, Cindy, Alice knows Bob, Bob knows Cindy, and Cindy knows Alice. So that's 3 mutual friends and 3 mutual strangers. So what I did here with the picture is I drew 6 dots. Oh, okay. I drew 6 dots and then I just colored them if they know each other, don't know each other, and then I looked for triangles. And now in the group activity, we're just gonna try to find the youngest person and draw get everybody's name and maybe their first letter or something, or initials, make a little picture with everybody, and then connect people if they're friends or if they know each other before the class or did not know each other before the class. And then we'll see if there's any triangles. Awesome. Okay. Let me see here. Okay, welcome back, everyone. I'm glad it's cool to see your friend graphs and which one, which of you knew each other before, which of you didn't. There was some where a lot of people knew each other, and there's also some groups where like nobody knew each other, like only a handful. So that was neat. And I think everyone observed in every group it was impossible to have a group without a blue triangle or at least one red triangle. So at least one triangle had to exist. And can anyone share how could you draw a group of 5 people but not get a triangle at all?
I have one.
Yeah, go ahead, share it.
Okay. I don't know if you could see it, but I did
Yeah.
a star and then I did a pentagon.
Excellent. Awesome, Gabby. So we have the star, like a pentagon. Oh yeah, we have the pentagon on the outside. And then on the inside, we draw the star. Oops, no. What did I do there?
Shoes at mine, yeah.
Okay. So does everyone agree that this is 5 people that know each other, don't know each other, but there's no group of 3 people that all know each other, and there's no group of 3 people that all don't know each other mutually? Yeah, exactly, Archer. Yeah. So with 5 people, that works. If you try to do this with 6 people, do you see what's going to happen? If we do it with 6 people and we try to do the same strategy, because if we could do it with 6 people, then the formula would be, then the statement would be false, because then I could draw something with no triangle. So 1, 2, 3, do a pentagon on the outside. But if I try to do this with and connect everybody inside, then I get, I'm going to start to form a problem because, let me see here, like that. There's quite a few blue triangles. So this shape doesn't work for 6 people if you try to construct it. So do you guys think you can try to come up with an argument to show that it's impossible, if you have 6 people, it's impossible to draw it without ever making a either a blue triangle or at least one blue triangle or at least one red triangle? It's impossible to do it. Anyone think they can come up with a little argument or kind of any ideas? And by the way, is it clear now kind of what the question is talking about? Cool. So I'll go, yeah, anyone want to kind of, it's a really interesting argument, but it's quite easy if you've, it's easy once you see it, but maybe it's a little bit tricky to get to it. I'll give you guys a hint. So let me give you a hint how to make the argument. This is the proof. And then maybe I want you guys to kind of see if you can fill in the holes and or move the argument along. So the argument that we're going to make is we're going to try to make a picture, try to draw a picture with no, try to draw it with 6 people, and we attempt to draw no triangles. And we'll find, hopefully, that this is impossible. The goal is it possible? Or we're going to convince ourselves that it's impossible. Okay? So we have our 6 people: Alice, Bob, Cindy, Dan, Evan, and Frank. And when you start to draw this picture, let's say we started Alice. What is one possibility we can do for Alice? So let's say I do blue, 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 red, red. Okay. So nice, Archer. Can you expand on that? So you said because you're forced to connect with at least 3 people. So why? Maybe I could have done. So is it possible for me to do from Alice? Can I do 2 blues and 2 reds? Can I do less than three edges of the same? No, I need to have at least 3 people that have the same color, that all match the same color to Alice. Does everyone agree with that? So no matter how you draw it from Alice, there must be at least, exactly, it could be either 1, 4, 2, it could be 1 blue, 4 reds, 2 blues, 3 reds, 3 blues, 2 reds, and 4 blues. Oh yeah, and also, yeah, it could also be all blue and all red. So this important observation is this is part of something called the pigeonhole principle. And it's a really simple idea. It says, like, if you have 10 baskets and you put in 11 eggs into 10 baskets, do you guys agree that there has to be at least 1 basket with more than 1 egg? That's all that's happening. We have 2 colors that we're putting into, we have 5 people that we're putting into 2 baskets, a red basket and a blue basket, right? And there must be 1 basket that has at least 3 or more people. That's all we're saying. So there must be 1 color that shows up. So there must be 1 color, blue or red, that shows up at least 3 times. The pigeonhole principle is a really, really simple principle, but it's one of the deepest ones, and it can get you to, like, really interesting ideas. And it's incredible how simple it is, but very powerful. Okay, please hit yes if you understood that idea, because it's a little bit, you might not have seen that idea before. So, like, no matter how I draw it, there's got to be 3 edges of the same color. They could all be either red or blue, but at least 3 have to be the same color. Could be more, could be less. Could be more of the same color, but at least 3 have to be the same color. Okay, so because we don't care if we're looking for a blue triangle or red triangle, let's assume that we have this configuration. So we have 3 blues and 2 reds. And, you know, it could have been 3 reds, and then we would do, instead we'd do the argument with 3 reds. But blue-red is kind of interchangeable. So let's just continue with 3 blues. If there's 4 blues, that's fine. Or if there's 5 blues, that's no problem, because we're only going to focus on the 3 blues. Okay, now let's focus on this region right here. So the 3 blues that we got. Now it could have been, by the way, it could have been B, D, and F. Those could have been our 3 blues. But I'm just drawing it this way so that it's easier for us to see something. Okay, now remember our goal. We want to avoid making a blue triangle. So how should I connect B and C? I want to see if it's possible to not make a blue triangle. Is it possible? So I should make them red, right? What should I make C and D? C and D should also be red. If you want to avoid, so assume that we have the configuration. If you want to avoid making a triangle, BC should be red. BC and CD should both be red. Okay, now does anyone see something funny that's going to force us to lose the game or force us to make a triangle? No matter how hard we try, what is going to make us have a guaranteed triangle now? Who do we have to connect in this picture that's going to force a triangle? Does anyone see a pair of friends? So FE. Well, FE, if I could also make FE blue, so that would be okay. DE could be a blue. E and ELF, or yeah, does anyone see ED? You know what? If I connected ED either red or blue, I wouldn't have a triangle. Yes, BD. Exactly. Does everyone see that BD belongs to two kind of possibilities? It belongs to this one, but it belongs to this one also. So it belongs to this one or this one. So any color you pick, you're going to get messed up because you're going to make a triangle. So coloring BD forces a triangle. Okay. Okay. And so this is something called so what we found here is that if you have 6 people, it's impossible to make a drawing, kind of like we do with 5 people, where you don't have a triangle. With 6 people, precisely because it's 6 people, there's 5 people left over, so you got to have at least 3 of one color. It's precisely that fact that makes this configuration required. With 5 people, if you start with Alice, right? If you look at what Alice is doing, Alice knows, and every person knows exactly 2 people and doesn't know exactly 2 other people. So Alice doesn't know those 2 people, but Alice knows these 2 people. So, and every person is the same. They don't know 2 people, but then they know these 2 people. So because you don't have a group of 3 that you have to all either all know or don't know, it's that group of 3 that messes you up a little bit if you try to not make it. So I'll let you think about it, but overall, please send me a chat, or I'm curious to hear, what do you guys think about this idea and this proof? Did it make sense now, or is it interesting? Do you have nice, cool. I really like this because when I first saw it, it was not similar to kind of a lot of the arguments I'd seen with equations and stuff, but I really like kind of working through that idea. It's a very nice idea. And believe it or not, this is actually something related to something called the, I believe, I don't want to exactly, something called the, I think, Ramsey conjecture or chromatic number. Let me see. I'm going to look something up really quick here. Let me see here. Yeah, so coloring, different ways to color a graph and get like a certain shape is a interesting part of graph theory that we kind of talked about with the handshake theorem. And if you guys are interested in reading more about it, this is related to the idea of the chromatic number. Chromatic means color, and chromatic number in graph theory. Okay, so let's move forward a little bit. I'm glad you guys like that. And if you like that, I really encourage you to, if you have a chance, and maybe I'll share some articles, like take a look at some of the Wikipedia or you know, YouTube videos on graph theory. I think that's pretty cool. Okay, let's try. Let me see here. Okay, here we go. I want to do a 3x3 system using matrices, because last time we only did 2x2. Now I want to do a 3x3, and yeah. So let's try it out. So we have whoops. We have x plus y minus z is equal to 3. This is negative x plus y plus 2z is equal to negative 5. And we have 2x minus y minus 3z is equal to 9. All right. So probably if we were doing this the old way, using just regular elimination, I think many of you noticed, oh yeah, it would be convenient to eliminate y because like these are all just plus y's and minus y's. So that's probably the approach you would do. But let's use matrices just to kind of see, practice doing more matrices and do a 3x3 system. So, and after we do all this with elimination and Gaussian elimination, at the end, I'll show you a way to do it that you can just plug, there's a nice formula that you can just use the numbers in the matrix and a certain pattern of multiplication and computation so that you don't have to do any of this, you just get the answer. But it's important to know how to do these steps and how to do them carefully. So 1, 1, minus 1, 3, minus 1, 1, 2, negative 5, and this is going to be 2 minus 1, negative 3, and 9. Okay. Thumbs up or yes if you are comfortable with this. This is called the augmented matrix. And we're basically just going to do elimination on this to get to make this. Our goal is to turn this matrix into 1, 1, 1 and 0, 0, 0, 0, 0, 0 everywhere else. Okay. Any questions on this? Okay. So we start like we do. Do we have a 1 in the top left? We do. We have a good pivot. So now let's use that pivot to eliminate everybody below the 1. So in particular, I'm going to keep the first row. So I'm going to do 1, 1, minus 1, 3. And then, and I'm going to just ask you guys to try to do this in your head. So just be careful and do it carefully. And then to eliminate this negative 1, I need to do row 2 plus row 1. they would cancel. Okay, so I'll give everyone a minute, and please message me the 4 numbers that you would get in the second row now. Or you can also just, if you want to raise your hand, I'll just call on you, you can say it. Hannah, perfect. Nice. Hannah, you want to just say what you got?
I got 0, 2, 1, and -2.
Awesome, thank you. Excellent. Okay, so that's the second row. We got a 0 there. Now we want to also get a 0 in here. So we can combine the steps. We can just do it over here. What formula do you guys think we should use over here if we want to cancel out the 2? Nice, we do R2, the second row, minus twice the first row. Okay, same thing. Please message me what numbers you get when you do this pattern and replace the third row with R2 minus 2R1. Oh, I'm sorry, not R2, R3, my bad. And that's the advantage of having a 1 in a pivot position is yeah, you're very close. I think, yeah, I think you're super close. You just missed, I think, 1 number. Nice. Yeah, yes, let me get some more answers. Nice, Hannah, well done. Savannah, the third number. I think the third number is a little bit off. Lily, check out the second number again. Nice. Awesome. Okay, so the numbers here that I'm liking are, so we have a 0 here by design, and then -1 minus 2, -1 minus 2 of these, that's going to be -3. And then we have -3 minus 2 of these, but this is -1, so it's like adding 2. So that's going to be -1. And the last one here is the last one here would be what is it? 9 minus 6, which is going to be 3. Okay. So now, right now, let's try. Does it look good? It's very possible I can make a mistake doing this. So any questions so far? So the next number that's the pivot is the next diagonal 2. And unfortunately, this 2, like, I don't like to have fractions. So this 2 doesn't just become a, it doesn't just turn into a 1, unfortunately. Because if I want to divide everything by 2, I'd turn this to 1/2. And I just like to avoid fractions. So instead, we're going to do something, let's see here. Well, let me think. There is something you could do. Yeah, there's something nice you can do here. there's a few approaches, but I'm going to just go with the standard approach here. R2 minus, now R1 is kind of like it's already done with until the very end. So now we're just going to focus on how can we use R2 to eliminate the guy below. And maybe potentially the person, the row above as well. So let me try this. So what you can do here, oops, that was the book. What you can do here is to use the 2 to eliminate the -3. It's similar to kind of what we did with elimination when you have different coefficients. So this is 3, this is 0, 2, 1, -2. And then this one would be, you make two, you turn them both into 6. So this would be 2R3 plus 3R2. So this is going to be 0, because 0, 0. This one would also be 0. The last one here would be, the last one would be what? -2 plus 3 is going to be 1. And this one would be 6 plus -6. So this would be 0. Okay. Is everyone okay with that last row that I wrote? 2R3 plus 3R2? Do you guys see why I wrote that? Please hit yes if that made sense, or no if I kind of because okay, a few people say yes, a few people say no. So okay, a bunch of people say no. So what I was trying to do there is, you see I have a 2 here and I have a -3. So if I multiply the second row times 3 and the first row times +2, sorry, the third row by 2, and I add those 2 rows, that'll cancel. It'll give me 6 minus 6, which will, and I replace it here, it'll become 0. So that's kind of why I have the 2 and the 3 there. And then the rest of it, I just did the same pattern. So if I have a 2 and a 3 here, oh, hang on. Oh, no. Sorry, the 3 is over here and the 2 is over here. So 3 times 1 and 2 times -2, that's going to be 3 and -2, which will be +1. And over here as well, if I have a 3 times -2 and a 2 times 3, that's going to be -6 and 6, which combine to a 0. Those of you, did that help a little bit? Those of you who were a little bit not sure with the steps? Or is it still? That's still a little bit, okay. Yeah, so, and I apologize that, I'm kind of doing some steps without writing it, but if you start to write everything down, it can get really, really messy. So I recommend just staring at this later, making sure you understand kind of how I'm doing each step. All right, now we're good because we have a 1. We have a 2 here. You could, if you wanted to, you could divide everything by 1/2. You're totally allowed to do that, but I don't like doing that because I don't like fractions. So I like to avoid fractions. But this is good because now I have my last pivot, and I'm going to use this pivot to back solve. I'm going to use this pivot to erase everybody above me. So when I do that, and here I'll end the class soon because we're almost out of time, but this will be 1, 2, 1, 2, 0, right? And I'm going to replace this row with R2 minus R3, and this will be R1, sorry, plus R3. Because that's 1, to get rid of this 1, I have to subtract, these 2 want to be subtracted. and these guys want to be added. So that would make this 0 and 3. And that would make this number 0. This stays as 1, 0, 0, 0, 0, 1, 0. And this would come 0, 2, 0, -2. Because, you know, this last number, when you subtract it or whatever, or add it, it's just 0. So it's not going to change the 3 and the -2 at all. Okay, now we're almost there. We want to get we want to get all ones in here. And now I feel comfortable turning this into a pivot of 1. You could have done it earlier. You don't need to wait till this step to do it. But now I like it because I don't need a fraction anymore. This is 2, -2. I can just divide everything by 1/2. So I can divide that row by 1/2. So I can do R2 divided by 2. So when I have 1, 1, 0, 0, 1, 0, 0, 0, 1, I'm almost there. This would be 3, -1, 0. The last step, the very last step, anyone kind of want to tell me what the very last, do we need 2 in row 2 to become a 1? Yes, I like to make it a 1. So that's, I did it at this step because I could avoid fractions. If you did it earlier, you would be totally fine. You would just need to, you just have some fractions. Great. We can now use this pivot, this middle pivot. We can back solve and go up. Whenever you use a pivot to erase up, it's equivalent to back solving. Like when you have an answer and you plug back in to get it, to get the other missing variables. You could have done this earlier in the process. You could have actually done this right here. And I probably would have done it if this was a 1. But because it's a 2, I didn't want to mess around with like trying to do 2 of these. I just didn't want to mess around with it. But you are able to move up later in the game if you want. Okay, so when we do that, the last thing we'll get is going to give us the answer. R2 stays the same, and then but R1 will be replaced with R1 minus R2 to make that middle term a 0. So this will be 1, 0, 0, 4, 0, 1, 0, -1, and then 0, 0, 1, 0, 0, 1, 0. So this reads our solution now is going to be x equals 4, y equals -1, and z equals to 0. Okay. All right, guys. On Thursday we will. So this process, like as you see, is it's pretty systematic. It's nice, like you target, like you do this elimination. It's called Gaussian elimination. You target a final shape, and that shape will just read off the answers. On Thursday, we're going to start to see another concept that will give you like a nice pattern or formula, so that you don't need to do all these steps. You just can plug it in. You can give it to a computer, for example, and the computer just spits out a formula and gives you the answers. So we'll learn how to do that. And it takes a few steps to do it, but it's a cool thing to know. All right, guys, have a wonderful rest of your day. Please think about this friend problem. See if you can recreate the argument later, and make sure you understand it. All right, I'll see you next time. Bye.